No. Hey, greetings and welcome. We're taking a look at page 357, talking about the quadratic formula and the discriminant. These problems had the following instructions. They said, find the value of the discriminant and describe the nature of the roots, real, imaginary, rational, irrational, of each quadratic equation. Then solve the equation. Okay, good. So first things first, I can't simplify this in any capacity, so I'm just going to say straight up A equals 3, B equals 11z's, C equals 4. And I'm going to plug that into the discriminant. The discriminant was this formula, D is equal to B squared minus 4AC, AC. And depending on the value of D, we were able to know the nature of the roots, or the kinds of solutions, or the kinds of x-intercepts we're talking about. So that's what this is referring to, the nature of the roots. So b squared minus 4 times a times c was the following. And 11 squared is 121 minus 4 times 4 is 16 times 3, what's that, 48? I think so, that sounds rightish. Yep. And 121 minus 40 would have been 181 minus 8 would have been 70. Uh-oh, guys, my brain blanked. 3? Okay. Whew. All right, so looking at this, you can see that it is positive. So a positive discriminant tells me what? That I have
2 solutions.
2 real solutions. And this is not a perfect square. So what else does that tell me? That they are irrational.
Wait, what are perfect square things again?
4, 9, 16, 25, 36, 49, 64, 81, hundo, 121, you know what I'm saying. It's numbers that if you take their square root, it gives you a plain old integer. Well, technically, I guess a natural number or a whole number. That could be 0. So anyways, so that's the nature of the roots or types of solutions. Now we actually are asked to solve this. And we were to solve using the quadratic formula, which was x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So plugging this in, actually I want to point out that I already evaluated b squared minus 4ac. What was b squared minus 4ac? It was 73. So I'm not going to have to re-evaluate that. So I'll just get x equals the opposite of 11 plus or minus the square root of 73 all over 2 times a was 3. So let's simplify this a little bit. X equals negative 11 plus or minus 73. I don't think there's a perfect square that I could break that into. It's not negative, so I don't have to pull its eye out. 2 times 3 is 6, and I can't simplify nothing. So those are my 2 solutions. Notice 2 of them there, just like that. Let's see. It says express irrational roots as exact and approximate to the nearest hundredth. So here's the exact value. So now let's actually figure out the approximations of this. So I'll maybe do this, break this into the 2 cases. What is the square root of 73? It is 8.54 hundredths, so 2 decimal places. So this is the same as x equals negative 11 plus, what was that, 8.54 all over 6. Or x equals negative 11 minus 8.54 all over 6. So let's evaluate both of these. One of these, negative 11 plus that, is going to be 2.456 divided by 6 is negative 0.41 when I round to 2 places. It was 409, so I had to round up. Oh, and actually this technically should have been squeakles signs because they were squiggly equals. Rip. Also, I've actually heard online this being called a zequels because of the zigzag nature of it. So I'm glad that other people use interesting names for their symbols. Let's see, negative 11 minus 8.54. I get negative 19.54, divide that by 6, and I get negative 3.26 when I round up to the 2 decimal places. So here's the exact answers. Here's the approximations of those answers. Here was the nature of the roots. Notice irrational, irrational because of the square root there, right? I couldn't simplify it any further. So the discriminant was right the whole time. Craziness. So let's look at one more question, a little bit easier, arguably. First thing we got to do here is set it equal to 0. So subtract 6x from both sides. These guys are not like terms, so I cannot combine those, as I'm sure we all realize. And if you really want to be unnecessarily, writing things, you could write a plus 0 there just to make it really obvious when you figure out your A, your B, and your C. So let's see, A is 1 because of the leading coefficient, B is negative 6, it includes the sign, and C is 0. So let's plug that in the old discriminante. D is equal to B squared, so negative 6 parentheses squared, because that's different if I don't have the parentheses, minus 4 times 1 times 0. D is equal to negative 6 all squared is positive 36. I like it. And negative 4 times 1 is negative 4 times 0 is 0. So here's the value of my discriminant. So what does that tell me?
That it's you're going to have 2 real solutions and it's rational, right?
I like it. 2 real solutions. And they are rational. Right? And actually even more so, because this is a perfect square, I also know that the original problem is factorable. But your book isn't necessarily interested in that fact, but I still find it to be valid and interesting nonetheless. So now that I found the discriminant, they wanted us to actually solve it. So let's do the quadratic formula. So x equals the opposite of negative 6 is positive 6 plus or minus the square root of b squared minus 4ac. I already calculated, so I might as well just write the square root of 36, am I right?
You're right.
All over 2 times 1. Man, that's the best version of the song so far. Remixed. Here we go. X equals 6 plus or minus. Wait, I know the square root of 36. That's 6. What? Divided by 2. This has, let's break this down. X equals 6 plus 6 is 12 over 2. 6 minus 6 is 0 over 2, right? When I kind of break that into the 2 possible situations we've got going on. So I get x equals 6 as one answer and x equals 0 as the other. Notice these answers are 2 of them, and they are rational. They are numbers that do not have crazy square roots or infinitely long decimals that do not repeat. So, so that's the idea. The discriminant was this first part right here. It also sometimes is called the radicand of the quadratic formula because it's the radicand of the quadratic formula. It's the thing that was in the square roots. And by analyzing that, you can actually gather some information about your problem. So for instance, if I found out, if I was only interested in real solutions for some reason, why would you ever? I could use that, find out, there's no real solutions. I don't even need to solve this problem. I would just say no real solutions, something like that. But maybe you would also be interested in what those imaginary solutions were for some reason. So thanks for watching, Internet friends. Have a good day.